Thank you very much, Chester, for introducing me. Thank you very much for a very good introduction and for inviting me here. And good morning, everyone, or whatever your country, maybe good day, good evening. Really happy to see everyone and very honored to be invited here. So my presentation is about, evaluation of LLM and LLM systems. And I want to focus on very pragmatic approach rather than going into like all science theory, more like how you can use this to build your systems, build your LLM-based experiences, apply LLM in your companies. I wanted to emphasize importance of evaluation. I help many companies. I did my work with LLM Science in Zillow and help many companies now. And what I frequently see LLM evaluation is a bit neglected. I want to emphasize, evaluation for me is the most important thing for any AI, machine learning-based experience. And I think good example here, you can see what I saw when I was in early Google. I believe one of the reasons why Google succeeded as a company versus competitors was better evaluation, because evaluation in AI is not just evaluation. It's like the way you tune your system to evaluation. You improve your system by evaluation, right? This is the way your system develops. That's why evaluation is really important. And as head of OpenAI sales, evals are surprisingly often all you need. And another is like recent post, I think it was yesterday from Andrei Karpathy, who said as a scientist, 1/3 of his time he spends on eval, because create right evaluation for your system is I think it's 80% of success, right? Because then you have to, of course, tune system to your evaluation. But evaluation defines what you will tune it to, right? That's why I see evaluation is super important. And that's why I want to talk about this in this topic, to emphasize importance of evaluation and how to do it well within your company. I wanted to emphasize, I give two types of talks. Some of them are deep dives into particular methods. This more is like overview of the best practices, because all your companies different, all your LLM use cases are different, and none of articles, papers published will directly suit you. It's good start, but it's more about learning from them, how you can build your evaluation based on those papers, right? And that's why in this evaluation, this presentation, I want to give more overview of different good practices, such that you can apply them in building your LLM models and building your LLM-based systems. What's the best to learn and to use, rather than, okay, let's discuss this particular method. Just why I'm talking about this. I spent around, now I started in Google 2006 after my PhD, spent almost 2 decades in building high-load, large-scale AI-based system search recommender engines, right? And of course, also a lot of experience with language models. Well before BERT and other, right? In 2006, we were already using them. Traditional n-gram models, and they had very big value. And of course, then around 2019, BERT started being actively used and so on. So I have a lot of experience in building AI-based systems and language modeling. And I wanted to share my experience because I see a lot of things are very applicable and current LLM worlds and what the best practices could be. I wanted to emphasize, again, there are a lot of LLM evaluation methods. And I don't think many companies will be building pre-trained models. Most of companies will use some open source pre-trained models and build on top of them. So we will not focus on metrics which are used at the first pre-training stage. In this discussion, we will focus more on metrics which are fine-tuning and struct tuning. This is where you tune LLMs for your particular business cases, for your customers, and of course LLM-based systems, how to evaluate whole system which use LLM, right? So focus of me on this story will be about this green squares, about not pre-training evaluation, but more about fine different types of fine-tuning, because this is where happens when you really focus on LLM for your customers. And I will talk about those methods rather than, I would say, basic methods of how you evaluate pre-training. So what's different from my practice, what I see? In companies who develop LLM, and LLM is foundation model in nature, right? So in classical machine learning workflows, one model was used for one particular task. Sometimes it's a little bit more, but you had very particular model for a particular task, let's say price prediction or demand prediction, and it was kind of easy to evaluate because you had more or less one number. It's a simplified picture, but it's more or less true, right? With foundation models, including LLM, one model is used for tons of very, very different tasks, not just even similar tasks, very different in their nature. And then teams, your science teams, which trains models for your company, has to create model which satisfies many other teams, because every improvement of LLM models should transport into improvements many use cases used by product teams, by business teams, but also create complexity, right? How to support this continuous development across multiple different channels the model is used. And even more complex, this is a picture from a paper, right? But this is true in many companies. So those like NLP tasks, and I'm talking about language models, I'm not going even into visual models. There are many different basic NLP tasks, which are, there are many more of them use cases and business cases, right? And when you improve LLM, you want to improve all of them, right? And the question how to evaluate your LLM. So how to create this pipeline as your science team improves LLM to be moving to the better to all tasks rather than you improve something and some other decreasing, right? So this is a complexity of LLM evaluation, because not one metrics, but tons of metrics for your LLM evaluation. And not only different NLP tasks, also different semantics, because, you know, like, say you create a typical example, what I see from many companies, you create LLM, let's say for search, which is as e-commerce or something else driving your company. But then financial departments wants to use this, accounting departments wants to use. There are very different semantic cases, right? And performance of LLM is very different for all of them. So here is like, you see picture is a report card from one of the model recently released from 10x, right? And they compare to different models. And you see different models behave very differently for different tasks. For one task like coding, GPT-4 is better, but for role playing, it's worse than this model, right? And the same you will see when you release your LLM models and you compare them. You see they behave very differently for different tasks, and it's really important to understand when you evaluate models by the semantic task and create your evaluation harness in your company to evaluate model by different tasks, because behavior can be very different and it can transfer to your customer experience as a positive or negative. So like LLM selection, LLM tuning should take this into account. Again, another difference in LLM evaluations, there are many different, besides NLP tasks, many different fundamental capabilities. LLM encodes knowledge, but it's also reasons, right? Creates own how you're going to evaluate these different tasks. For some use cases, only knowledge is enough. For some, reasoning is important. Frequently, like if you have LLM predicting price, you have a lot of on top of the, sorry, not LLM, model predicting price. It's not directly exposed to customers. You have a lot of on top of it to verify if model produce something wrong. Frequently, LLMs are directly exposed to customers, right? In search, in recommendation, and chatbot experiences. And if LLM does something wrong, it directly goes to the customer. Very big, high risks, right? So high risk of LLM exposure creates, of course, a lot of requirements to your LLM evaluation. And I think, you know, like recent, like what happened with Google, other companies, when chatbot or image generator was creating something which people did not like, and it get a very big exposure to the media, is a good example of high risks of LLM evaluation not catching something. So coming back, right? So now I will talk about how to build evaluation process, and then I will talk a little bit more about particular evaluation methods, which I believe are really good practices. So how to build evaluation process in your company, right? There are a lot of things which are naturally hard in LLM evaluation. For example, subjectivity of text, right? Comparing if you produce number, price prediction, easy to check. Text along, there are a lot of subjectivity to evaluate text, how to, like, if you have a golden set of writer evaluation, is this text the same or not? Or like, is it good answer or not? There are a lot of subjectivity. And I know many cases, like, for example, in one company, they developed a chatbot based on LLM, right? And they rated with humans. And humans, when they were asked to respond to, like, human raters, were asked to respond answer, to correct answer, preferred long answers because it seems kind of really nice, very long answer, right? A lot of like a lot of information. But when they rated this with a when they measured how people, customers really interact with the system, actually people prefer much shorter, more concise answers, right? So, but raters, when you ask them what makes good answer, preferred long answers, good example of subjectivity. And there are many other examples when raters can introduce their own bias, subjectivity, and it's important factor when you evaluate LLM, because evaluation of text is naturally complex. Again, frequently evaluation requires, like you're building LLM for, let's say, financial question answering, requires expertise, domain knowledge, reasoning. Answers are long, right? Is this answer correct or not? requires its own complexity. Is it like you have assume you have golden set writers answers? Is this answer represents the same information or not? For long answers, it's actually not trivial problem, right? Requires a lot of semantic matching and so on. And just good examples, there are reasoning tasks. You can go through these papers where like interesting ways to evaluate. Multi-turn tasks are very complex to evaluate how multi-turn interaction system, is it correctly behaves or not? There are good examples, or instruction following. Why to evaluate LLMs, right? I think the one like the most important, kind of the last thing here, because really for every AI, machine learning driven customer products, development of the products is driven by evaluation. So having a right evaluation, you move product into the right direction. That's why it's so important to have right evaluation. Of course, as you launch new products, yes, no decisions. Typically, the way you want to evaluate your LLM, is it ready or not? And then, of course, validation of every product improvement. Do you really improve this or not? So there are different things like, like yes, no decisions, continuous improvement decision, driving development. Why do you use LLM evaluation and why it's so important? It's really important also when you build your industrial, right, for your customers. So business cases, when you create your like cases, like academic community frequently likes these big benchmarks and they use kind of average case, right? Frequently in real world, worst case behavior, best case behavior important, and it should be also part of your evaluation. Like for example, with toxicity or like racial something, right? Or like it's really important to understand worst case behavior rather than, okay, in average 99% of cases it looks good. In some cases, 1% of bad cases can be really bad and stop for your LLM use case, right? So it's really important once you build your LLM evaluation frameworks, understand what will be real outcome, what will be real risk, and based on this, do you want average case, do you want average score, do you want worst case score, do you want best score? It really depends, right? And also important to understand risk as a part of your evaluation, not just NLP metrics, but really risk which predicts your user behavior. Important to have semantic coverage. I notice sometimes people make a focus for one particular, like we're building e-commerce search. Let's focus on how we understand products, but then financial team use. You need to understand all these different semantic areas and build LLM evaluation for them. And it's just necessarily complex, like comparing to search engines, which has many, many different metrics. Important frequently, like in companies, LLM like improvement is continuous cycle, right? So continuously you need to do it, continuously improve. And that's important to create your LLM evaluation process, which will be supporting this frequent evaluation by your scientist, which will support continuous improvement. And again, frequently it means LLM improvements, ROI improvement for many downstream use cases for many product and business teams which use this. That's why it's also very important to build this very fast iteration cycle such that scientists can focus on LLM improvements and they will bring a lot of improvements into product use cases. So to build evaluation cycle, like LLM evaluation as a cycle, not just as like one-shot operation, but something what hopefully you can create new version at maybe weekly or maybe even more frequently with continuous improvement. Evaluation process must be fast and cheap and automated, right? And some evaluation methods, they assume you have to run against 100,000 tasks. Each of them requires a lot of reasoning, right? So just running through this benchmark requires very long run, or sometimes bottleneck like human eval, depends. These are different bottlenecks, which creates a lot of problems. It's good for rare events like pre-training and release of the big LLM, but certainly like continuous improvements cannot be relying on expensive, slow process. So evaluation process must be fast and cheap and automated also. Of course, evaluation metrics must be correlated with customer and business metrics, like some metrics, let's say fundamental like perplexity, right? They're not really representative of customer experience. So like evaluation metrics which you build must be much closer to customer experience or should be at least proven such that they represent and correlated with this, right? It may be more fundamental metrics, but at least it's really related to final customer task. Like if you for example, if you have beta embeddings, then recommendation engine, which based on this embedding, when you improve embedding, really improves customer conversion. And again, evaluation suites must cover very different aspects of use LLM, not just one particular. So your evaluation tools, your evaluation suite must represent all these downstream use cases. what kind of I see necessary requirements for LLM evaluation? A bias free, and again, like there are a lot of subjectivity. This would be a good example of bias when raters, what I described before, raters like longer result, but customers really don't like them. And there are many other similar biases, like can be language bias, maybe different a lot, many other things, like representation, right? Whole your metrics as a number, formula is just part of the picture. Of course, data set or like how if you sample from live traffic, right? There are different ways how you evaluate LLM. Must represent your whole customer experience, like who must represent your customer. Like I saw like people create a good formula to compute certain LLM metrics, but their data set is artificial, is not really representing customers. So like they fix it at a certain time, customers shift over time, and they don't move data set to represent current customers, right? So representation is really important of part of LLM evaluation. Alignment, atomic measurements, like formula should be aligned with customer or business quality. Another really big part is systems, right? So what we discussed, it should be cheap, fast, measuring the intended, like if you measure evaluate LLM in production. Of course, this measurement as you sample should not delay your system or overload your system, right? Or like, again, as scientists do offline evaluation, it should be very fast, should not delay work of scientists. And again, statistics is also important. Like I've noticed, like, for example, it was recent Wall Street Journal evaluation of chatbots, right? And they created like 5 different areas, and they create 3 prompts for different areas. What you can judge from, of course, it's some kind of good, how to call, anecdotal experience evaluation, but how you can compare, let's say, ChatGPT versus Google system by 3 prompts, right? I don't think it's really creates you. And I see like frequently it's kind of extreme example, but there are many cases people say 100 examples, right? And when you ask what your confidence of prediction of like this model based on this, comparing to this model, if you have only 100 samples, right? And sometimes it's good, but frequently people don't have answers. And this is a really important part of your evaluations used to create right statistics. And also sometimes statistics help you solve other problems because you can understand that you don't need 10,000 measures to sample this, right? You need 200, and it makes your process much faster, much simpler. You can train your models more frequently. So those kind of 5 key dimensions, what I see necessary requirements for the good evaluation in industry. And going to particular evaluation metrics. I will start with embeddings, right? Because frequently when you talk about LLMs, you think about generative experiences. And of course, like as you know, like the kind of coming next. There are 2 big sets, like from this paper, right? There are 2 different types of LLMs and 2 different use cases, like 2 different types of models: decoder-based, encoder-based. There are embedding models such that output is embedding multi-dimensional representation of the phrase, and there are generative models which generate text, right? And kind of most of media attention is more like to generative models because it's very interesting, like it's really AI about how it's interact. But embedding models are driving many different industrial use cases. And perhaps now, in many cases, despite they don't get so much attention, they're perhaps more important because it's really about search, discovery, recommendation, personalization, many other cases where companies get really like value for customers and money. So let's first talk about embedding models because they're very important for the end customer experience. But there are many other use cases built on them because embeddings like clustering, text similarity, ranking based on them used in many other sub cases. And a good example of how to create a good evaluation of embeddings is this massive benchmark MTAP. And it's like it's available, like you can see a full paper about this. There is also leaderboard when they compare these different models, but this benchmark, everyone can submit their models. And what I like about this, what learn from this, it's quite comprehensive, right? They understand, like, like if you have multi-dimensional representation, embedding, it's not just one task. You have 8, like they put 8 different tasks. There are actually more tasks you can use based on embeddings in like production, but at least they select these 8 different tasks and they evaluate embeddings based on these tasks. And I think what's really important, right? Such that you see different models lead on different tasks. So like, like embedding is not one kind of, oh, this is the best embedding. They work differently for different tasks, and you see different models again lead on different, is of course it's more like correlated, like if model is best one on one, it may be in top three in another, but certainly you see not the one model leading all of them. And it's important in your also evaluation tasks to understand this for some kind of, like core NLP capabilities such as genetic embedding. Next step, you have to build evaluation for the next step task rather than just evaluate its core. And sometimes you have to create this granularity. And when we talk about hallucinations, it's another good example where granularity is really important and you have to understand different subcases in your tasks. What I like about the evaluation, like again, you can learn from there, you see different models winning for different use cases. And it's important to understand that frequently it's necessary to build more like multi-model, not multi-model, multi-model systems such that different models will be in your production serving different use cases. Easy to plug in new models, and this is like I think will be necessary in any LLM work. Easy to evaluate and experiment with different models, and to plug in new data sets for existing tasks, right? This is like MTM, they have open source suite. I will talk a little later about this. Another important, so they use kind of the standard metrics which are popular in community, information retrieval community for 30 years, like precision at K and DCG at K. And I think it's good, important learning here. Don't trust those metrics. I've noticed many companies use metrics from such papers default, but like these metrics were developed 30 years ago for particular use cases, which how people used web search 30 years ago, they're not applicable now frequently. And so again, you have to measure how your customers built your system and then build these metrics based on this, right? Isn't DCG at K is good metrics, and many use it by default. My experience, it's not for many use cases. It's based on this reciprocal models built many years ago. These people used web in the time of early, whatever, 2000, not the way they use now, right? So it's really important as you build your evaluation suite to question every part of evaluation, like including these metrics, right? So really fun metrics matching your experience. Again, another important part, good to when you talk about LLM embedding models, like many of them will be used in extremely high load cases. Like you will have million queries per second within your, because there are just so many customers, right? Or maybe maybe not million, 50,000, but still a lot, right? And because it's search or a recommendation, you have to create within like, let's say 50 milliseconds, right? Get your LLM work on that, or maybe within 100 milliseconds. So it's really important. One is LLM evaluation as a NLP engine, right? So for this task, like what quality of my embedding for text-based similarity, but also what latency, what throw output, like, like if I want to handle 50,000 queries per second, how many nodes do I need to deploy, right? This is a good example, such that we will talk a little bit more details about that later, but important part of LLM evaluation. Again, really important as you build for like embedding representation, your metrics, but your query sets to represent them, such that distribution of queries, the distribution of documents will be similar to your users, to your production case, right? Because it can behave very different for other properties, and you don't measure really your experience. So this is another big important part of evaluation, which is very clearly in such cases as embedding evaluation. And 1 second, let me move my, I don't like, yeah. And again, like really important to go and measure this task will be representing what is used by your users, like for example, text similarity and so on, to make this metrics as a key metrics of your evaluation. Hallucination. Now, everyone talks about hallucinations, and of course, they're really important, but I think sometimes also a discussion misleading. Like, for example, if you look into a recent discussion about Google failures with Google News Search, right? People blame, it's popular, like in Wall Street Journal, hallucination, but in most cases, those are not actually hallucinations. LLM produced the answer based on what source it's used, right? The problem is you like system which below used wrong source selection, like Onion, magazine or Reddit, right, which does not contain factual good answer for those queries. So it's very different. Like like it was not about hallucination, but still hallucinations are really important in many use cases, because you don't like you can imagine, especially some domain like medical summarization, right? You certainly don't want LLM make a mistake. So really important how to evaluate your system for hallucination, and because typically once you understand what type of hallucinations, you can find better ways how to fix them. And there are several good papers. which helps to kind of build your evaluation task. I think Halo Eval is evaluation benchmark, but I think what's really important to learn from there, not just particular benchmark, but they pretty well research hallucinations. They identify several key types, like where hallucination arise. Like question answering is one type of interactions. Other type is knowledge grounded dialogues, and another is text summarization, right? And they classify hallucination sites there because like once you understand these classifications, it's more easy to build your hallucination detection and your hallucination evaluation for your systems. And what's interesting, like question answering is kind of understandable, but what's important to note is that LLMs, even for such simple tasks as summarization, you have very clear input, you have to summarize this to produce output, produce hallucinations, right? And this is maybe more easy to detect because you don't evaluate versus whole knowledge versus very particular knowledge. But even hallucinations appear there, and good to see such that you can build the hallucination evaluation framework. Another really good paper for hallucination evaluation is this paper from DeepMind. Safe System was recently published. I think it was March or April. And what they do, they check. So LLMs are very good in you can use another LLM to break answer from this LLM into atomic facts, and LLM really good at this textual analysis. But then you can verify each fact with verifier versus ground truth. In that case, Google search in your system can be something different. Your search, your knowledge base, your graph, right? But it's a really good framework such that you take answers from LLM, use another LLM to break into atomic answers, and use whole system of verification of truth based on your ground truth. Pretty good method to evaluate LLM for evaluation. And there is another recent paper. Again, there is a leaderboard. They like compare LLMs, and another good learning from there. And you see it's pretty consistent across different hallucination evaluation tasks, breaking hallucination evaluation into subtopics. And it really helps to understand question answering, fact checking, summarization. They have own instruction following, right? Not just, okay, let's evaluate hallucination, but let's look into particular subtopics, because when you focus on them, you build much better evaluation suits, because those type of hallucinations very different. And would you ask human, would you use other LLM, you need to build very different procedures to evaluate hallucination by these different subtopics. Code generative. I think this is another good example. Like not everyone will build code generating LLMs, right? There are some companies build this, but I think it's a really important way to learn from how they would evaluate code generating, because what they found the best way is not to evaluate syntactic code or semantic code directly, right? It was old method how they evaluated code generating LLMs before. You're trying to analyze whole semantic of the program. You're trying to analyze whole program and understand its meaning. What they found, it really works well. Instead of this, you evaluate versus unit test, right? So you understand what functionality should be produced for this task, and then LLM produce you a set of different code snippets, and you evaluate will it run against this unit case, right? And I think it will be also applicable. I see it will be also applicable. Like LLM will be used for many like solving task, right? Not only necessary as producing a program in Python, C++, or whatever, right? But in some meta language which describes certain task, you suppose your LLM to, like your LLM-based experience to be solved, right? And then you can verify not just LLM program, but you can execute this program in some your domain-specific language to check if it works. And I think this very good will be applicable to many tasks beyond direct code generations. So human eval is really good when they introduce this method, right? Rather than before human eval, they were generating like trying to understand whole code of LLM, but in human eval, they moved into let's evaluate programmed task versus unit tests. And of course, some of these programs, they will not even compile in some cases, but some of them will compile and will not do what you want, right? And this is really good way. So for such task, when LLM is supposed to produce action or description of the action, you check this action not versus semantic kind of whole understanding of the code produced, but versus execution of action. And it will be applicable in many other tasks, like not just Python, C++ code production, but when LLM does other tasks, home automation, scheduling, and you see there are some good papers when you see better more details about practices. Another good paper to learn from, it's like they built Copilot in Microsoft, and they built really good evaluation suit for this copilot, right? And I see this is practice would be very usable for many other, like, like copilots is one of, I see many companies developing copilots for other customers or for some business functions. And the way they did this in this paper in Microsoft, really good way, because they did not try to evaluate any experience. They selected a set of sub-core, like, like documentation generation, bug fixing, code generation from natural language, key experiences, they believe, for this copilot. And I see it's the same in many companies for many other copilot cases. There are a lot of things you can do, but let's focus on key stuff. And let's focus on what we can evaluate, right? And this is a really good paper from Microsoft, how they evaluate Copilot, really select several functions, key functions instead of everything, and focus on them. Another big area of LLM evaluations is arenas, right? It's old method of evaluation, AI-based systems. Like Google was very heavily using this, and search engines I built, we used arena-based, like side-by-side, usually we call it side-by-side evaluation. You have two versions of your models, you have two versions of your systems, and then evaluate one versus another, ask customers, people evaluate, and it has a lot of advantages versus point-wise comparisons, because frequently you can get proper evaluation with much smaller sample set. It converges much faster. You can get a lot of, it's much more sensitive, right? Like, like if you move search engine precision-based metrics, it's very hard to find proper measurement, like when you improve precision by less than 1%. But side-by-side evaluations, they give you very reliable measurement. So Arena has a lot of very good advantage points you can use for evaluation. You can look into Chatbot Arena for generic use cases. I shared my repository of LLM evaluations. There are many other arenas there. Negotiation Arena, and good paper from Kahir about them when they look into like arena-based evaluation and what are strong and what are weak points of arena evaluation. This is another good one. Again, like arena, like kind of those big popular arenas, they compare models, but in your case, you can use also evaluate versions of the model. You create a new version of LLM for particular task, and you can use arena-based evaluation to compare versus older model. Is it good or not? And again, like arenas are much more sensitive than point-wise evaluation, and they produce a lot of more other detailed information. Results are easy to interpret, right? And possible to modify task, like different ways what you can get more from arena than from arena evaluations and point-wise evaluation. Useful for incremental improvements of the same model. Give you deep understanding of model change, because you can understand what really happened, like through different subdomains. Measures well both improvement and degradation. And again, useful in small code changes. And you see like Google Vertex AI has after side-by-side, what they call a side-by-side arena. So you like, and there are something like, I think Harness or someone introduces a part of another tool set recently. So you certainly see arena-based evaluation is spreading, because it's really good method, right? In context evaluation of models, there is also some evaluate this. It's one of the oldest tasks, and it's hard task because it requires understanding and reasoning. And there are several core in context learning evaluation sets, like as I think they like started being like from 2016. One of them, it's one of the most kind of typical task for LLM evaluation. And there is OpenACL framework software such that you can use to evaluate for your task. And why I believe it's important, because ACL in context learning will be used across many different tasks. You build user experience inside your system. That's why it's really important to understand how your system good in context learning, right? And several sets to learn from. Picker, right? It's all set, and they do like like multiple like it's for physical answer, but like you can easily apply the same principle to any what you build your customer shopping experience, like your question answering for financial, anything else. You can apply the same evaluation principle. You have a query, you have set of answers, you ask LLM to select the best answer. It gives you really good evaluation, both how much your LLM understand knowledge for your particular domain, but also how well it reasons, right? So this kind of evaluation is pretty, and there is older one, I think this is the oldest one, Lambada, is prediction next words. It gives also about deep comprehension by LLM. Context dependent is much more atomic, harder to ask creators evaluate good answer or not. You don't need to actually answer because you have target sentence, you don't need raters. But it also gives you core capabilities of LLM and other good. But like my preference is Pika-like evaluation, because it's really evaluate well and gives you understanding what are strong and weak points of your LLM in understanding knowledge for domain, but also in reasoning, right? There is ethical AI evaluation, one of the hardest topics to do ethical evaluations. And there are several good papers because there are different things from ethical. There are beliefs encoded in LLM and those biases. There are deceptive behaviors, right? Kind of give you some guidance. There are not really like super comprehensive benchmarks, but at least there are several good papers to understand how to evaluate what your LLM can do wrong if it's important for your system. Whole area is LLM as a judge, right? Because frequently, like your old evaluation was based humans as raters, but now you can use LLM as a judge for many tasks. You cannot do everything, but actually for some tasks, LLM does very good. And it's also much cheaper, much faster because you don't need to be dependent on humans. You can ask LLMs, right? It, of course, a lot of work typically to create a template grading. If you want to do a lot of this iteration work to create templates for judging LLM, to evaluate your LLM. But like if you make it successful, it's pays back because you create very fast, cheap comparing to humans evaluation suite, right? Again, a judge may agree with human grading. Not works in all methods. Cost can be much cost can be expensive. Typically, people use very advanced like GPT-4 or LLMs as a judge because their precision is better, but it's more expensive. You can experiment, create with cheaper, sometimes smaller models. And there is a lot of recent work, for example, such that replacing judges with juries with several 3 LLMs can help you because then you remove like judge LLM bias if you have multiple different LLMs. Evaluation of RAG, another important topic. When you evaluate RAG architectures, there are multiple different things. You want to evaluate search of your retrieval, right? Correctness, comprehensive, readability, depth, other metrics. And I think a good example of what Google done recently with Onion, and perhaps it was good from factuality and faithfulness point of view, one of key metrics, but it was not good from authority of information, right? And it's a good example such that your evaluation must build different metrics. Important, like when you evaluate a RAG, you have answers from LLM. You want to frequently want to compare with ground truth. And people typically use these old lexical metrics like blur, roach, then don't work really well. Like there are many more metrics BERT of smaller LLMs, like BERT score. They work well comparing your answer versus ground truth. And you want to look into like real semantic complexity. So there are several methods how to evaluate RAGs. Like one is RAGAS, and they have open source. They have kind of 3 metrics inside papers, and they added 4th. And now they have many more metrics, so it's really good to use this as an open source and build your. And this integrated with Llama, Index, LangChain, pretty good framework. So what they do, right? So basically, when you talk about RAG, it's very different from like traditional paradigm retrieve and then rank, right? You retrieve and then generate. And basically what you have like your retrieve context set of answers which you believe, and you create like a set of you create your answer from there, from context, right? And for Argus, you have several metrics. And only green one is when you need humans to evaluate this. All others can be done automatically. Of course, it requires some prompt, like some tuning, but basically it requires like answer relevance. Is your answer really related to question or something else, right? Faithfulness. Is your answer is generated from context, or it has some other facts, basically what we call hallucination. It's called, like here we measure with faithfulness. Context precision. Is context is really good context for this question, or it's something wrong, contains some off-topic answers, right? Those key metrics. And finally, context recall. Did you recall everything? What should be recalled? And here where you need humans to actually recall, compare ground truth, right? So those kind of 4 metrics such that you measure RAGs. I will be a little bit fast here because I see we're close to time. So those kind of give you key ideas how we measure RAG and what are key formulas, right? Again, it requires a lot of work from my experience because you have fine-tuned prompts to do this, right? For particular LLM. And again, what metrics you use depends on your domain. So you have this set of core metrics, but like, a good example with Google search authority. I don't know what was really evaluation method there, but, like good example in some task, authority of information really important. Yes, when someone asks, what should I do in depression, system answer, because some user on Reddit said you can, like in case of depression, jump from Golden Gate Bridge. It's not good answer, right? And key problem, it's not was hallucinated, but authority, it's like some joke, and you should not get joke in your context here. So the problem context was wrong, and it's about authority of context, right? Rather than giving magical query. And so in topicality, so to authority and topicality of context. So it's really important to build this evaluation for your particular cases. And again, good about Ragas, you have open source for this. I will skip another method. There is another good method from data metrics because we are very short in time. You can look into this.
Don't worry about the time. I haven't heard back from Joe, so you might have.
Okay.
Yeah.
Okay, and it's a good example. There is another method from ARIS, automated track evaluation system. It's from Databricks team. It's quite different. They focus on the same metrics, so those metrics are key and important to build, right? And it's a good example, but such that having a set of metrics, you can create a very different evaluation suits, a very different way how to do this. And what they built, they kind of, you can look in through details through paper. It has a lot of advantages to measure the same metrics, but very different way, right? And also very important what they've done here, like statistical, what I mentioned before, statistical methods are important here. So they created also statistical method, which helps you to evaluate the same number with much smaller number of measurement. And of course, it creates a lot of difference because those measurements are human-based. They're expensive and long time to obtain, so it creates a lot of difference, right? So let's go from picture, it's better. So they use, again, they create a synthetic data set. It's another method you see. Actually, LLMs are very powerful in creating synthetic data sets for many tasks, and they're really good. Sometimes you can represent your task very well. It's another big method. You don't need to collect, you can create synthetic data set. Actually, I'm planning to create code lab now about search evaluation through synthetic data sets. I will share it share it once it will be ready. But basically, good method you can create with synthetic data set. Having your corpora, you train LLM judge with synthetic data. So here's another what they use training LLM judge, and it's proof its own value. And then they also created the statistical methods which produce you with much smaller sample, but also gives you confidence intervals, right? So kind of high level explanation of this method. So it works quite different from Ragas. It measures the same sort of metrics, but different way. You generate synthetic question answers from the input corpus passages using generative LLM, right? So basically, they like what would be good queries for this document, right? Both positive and negative, so you can see answer, right? Then for each of these, having this kind of creating the data set, you have a ground truth, synthetic ground truth, but then you fine-tune LLM using binary classifiers, training objective, and you create this fine-tune LLMs for your evaluation tasks, right? So they create for these different tasks, they fine-tune LLMs to evaluate those particular tasks. And then they create this context the query answer for context triples and classify them using LLMs, right? Basically, they report the ranking of LLM comparison, not just pairwise, but whole kind of ranking-based LLM comparison is more reliable than point-wise scoring due to noise in synthetic data. And they report that they do more accurate measures than Ragas by adapting techniques to prompting and using the statistical method. And again, it's very important, want to emphasize such that for this RAG level evaluation, and basically the same methods are not only about RAG. RAG is very particular architecture. Like fresh prompt is another example. So when you use you want to have an advanced question system, question answering and search system using LLM, but instead of RAG is very particular. You create embedding, you transform your documents into embedding, you match them, you retrieve them. Like LLM as a tool, LLM using tools, search engine as a tool, this fresh prompt techniques, which was shared by Google, right? And now Perplexity, U.com, and many other search systems, which you see like Google itself, they use kind of similar technique when instead of RAG embedding-based representation, LLM sends transform a query, send to search, gets documents from search instead of vector-based retrieval, and then summarize answer from search. The same actually techniques like metrics very applicable to this very different systems, and I believe actually, for many use cases, the system has more features than RAG, right? Because there are a lot of advantages in all domains. There are knowledge graph-based kind of RAG retrieval, but overall, like for all LLM-driven search and question answering, basically the same faithfulness, kind of like context recall, actual factuality, the same metrics are used across all the systems. But what I say, like very important, once you build your system using LLM, very important tech metrics, like for example, authority is very important for some search systems. Freshness of information can be super important for some, not very important for others, right? To create this information retrieval metrics, again, like for example, magic of language, someone was coming to me, they have systems such that documents in Hindu, queries in English, how to measure this, like there are a lot of things, how to tune particular metrics for this particular system, right? So really important to create metrics for this. Data sets representing your document and users. And again, like as you use LLM as a judge to fine tune prompts for those. Another good examples of good practices of LLM is other domains, like for example, health LLM, a really good paper. They build health predictions for wearable sense data. There are a lot of interesting examples how to build LLM evaluation for those particular tasks, right? Explanation of recommendations, and really good this recent like paper from Nature, you can see. So they built a chatbot for healthcare cases, right? And if you look through this paper, there are a lot of evaluation details how to measure customer experience for this very particular use case, and it has a lot of particularities, how to represent information, make it interesting, understandable, right? And this is what you want, like you may build instead of healthcare for shopping or for ticket reservation, but each of the systems have very important way how customers interact, and which goes to LLM, right? And really important to build your LLM evaluation based for a customer, and this is good examples how you build such things. So coming back, as you build such tools, right? Like such tools are complicated, and frequently you can build them from scratch, but it's a lot of work and it's done by someone else. And there are a lot of really like if you want to scale your evaluation and you need to run across distributed LLM system, will your evaluation hardness support this? Like it would require a lot of time to build such system on your own. So there are a lot of good tools to use inside your systems, right? And what you want to make fast systems, scalable, easy to use code base, because none of this tool is 100% ready. You will need to adopt a lot of your tasks. You will have your metrics, you have your code, you have other tools like compatible with your system, right? Compatible with your inference layer for LLM and so on. Evaluable, you need to add new models, new tasks, new data sets, new metrics. And harnesses are evaluation harnesses, very complicated products. There are a set of them, like I don't know deeply all of them. I kind of did evaluation of evaluation tools. But some of them, like from my point of view, Letter AI, LLM evaluation harness is sort of leader. It has a lot of, like, it's compatible with, like many teams use VLLM as an inference tool. It's very well compatible with this. There are a lot of other tasks, like if you use MLflow, perhaps their own evaluation suite, because it's part of the tool set. But like from open source tools, like I found Letter AI evaluation harness very powerful, very strong, compatible, scalable. Like for example, Mosaic ML Composer. Mosaic is part of Databricks now, was like very well scaling to multi-GPU, but now they implemented this as a part of Letter AI. So kind of my own experience, again, I don't pretend it's absolute truth. Letter AI is a good one. And there are more particular tools like Ragas for LLM-based evaluation. It's like for what we described, that previous method, you can modify uses. Again, Letter AI, like perhaps if you go through LLM papers, I think 60-70% of research teams use Letter AI for internal evaluation. Hugging Face uses this. Very well integrated with a lot of open source software libraries at like both high level and low level libraries. Has any other things like LoRa adapter evaluation, right? Many metrics evaluation as part of the tool, such that you can easily adopt this. Scales well for multiple GPU. It's an important task, frequently integrated with LLM and other LLM inference tool, and easy to create new zero and few short task evaluation tasks. And kind of coming back what we discussed before about embeddings, right? LLM science evaluation NLP task is one really important task, but LLM will run in your production, right? And it creates certain load. Do you want to run it online with your customers coming and searching, and you create LLM to answer their answers, right? And then you might have, like, again, million queries per second or 100,000 queries per second, and requirements 100 milliseconds. So maybe your LLM needs to process billion documents per day. So you always have some certain production requirements which will be important for your use case. And then it's really important to understand, once you evaluate LLMs And it will also motivate your decision. Do you want to use this 10 billion parameter, 7 billion parameter LLM? Are you allowed, can you use like a 70 billion parameter LLM for this use case, or you have to go to 300 million parameter LLM? Frequently define what you allowed to use in this particular use case. There are multiple metrics, depends, like, and they measure different things, like you're looking to GPU utilization. I've noticed frequently some teams kind of over provision, and it kind of creates unnecessary costs of your LLM infrastructure, and maybe you have like 20% GPU utilization, right? Really important to look this. Of course, there are like with LLMs, there are multiple latency metrics. Depends, like, do you want total latency? Do you want to care about first time token? Do you care about time per token, right? Depends on your user's case, and really important to look latency, what defines your use case rather than, we measure some latency metrics. And of course, like operational metrics, like again, sometimes you can over provision, you can under provision, and maybe in some answers, some cases, your LLM infrastructure cannot answer that stream of queries, and you have model overloaded, right? How many of those? It's really important to build this whole LLM. It's kind of not LLM evaluation, but really important to have this metrics measuring your LLM cases in your production, right? It's not like LLM evaluation traditional, but I think it's really important from LLM evaluation from production, and gives you a lot of opportunity understanding what to optimize, because it really defines a lot of in other cases, right? And again, another important to measure, not just atomic low-level LLM functions, but whole your metrics. Like say you produce embeddings, right? And this embeddings used in your recommendation systems, and you created a new version of LLM, and it's created, let's say, better by similarity metrics, text by similarity. Does it mean that you recommend better items or not? Does it mean that people get more conversion and your business get more money? Hopefully, yes, right? But you have to measure this. And it's really important to measure this whole end engagement, especially as you deploy new models, how it affects, and user engagement metrics, response quality, just final user engagement end to end, but also how people interact with your LLM at more atomic level, like length of response, time between reading and responding, session metrics, all of them important, because LLM can either improve or can, degrade all of them, and it's important to measure. So it was my presentation. Thank you very much. I think we have time if no other speaker.
Yeah, thank you so much for Andrei. I just got back from Joe. Joe have a family emergency, have to attend a funeral, so he couldn't. So for those who want to listen to the Graph Neural Net, and I'll reschedule in July, because that time I'll probably also schedule a graph talk by the Tiger Graph as well. So we'll combine the two. I apologize for those who come for that. But Andrei, thank you very much for the great talks, and there's a lot of information in it. The first questions, actually 2-3 people asked the same question. Can you share the slides afterwards?
Yes, certainly. I can share even here. Let me share 1 second. I will share afterwards, but let me.
Or you can put a slide on chat, or later on you can send to me. I'll post it on the meetup page, and people can,
I can share here. Let me Google share anyone with a link. Let me and I will share later, but let's share here.
Yeah. Okay. And then this actually, I have several questions related to your talk. So most of the evaluation methods you talk about it just for the general LLM. Have you see the multimodal evaluation method? Like, for example, you have the image, video, text, and the audios and all that stuff, and that sort of I think for healthcare applications, suppose you have these multimodals, the people has a lot of stuff in it, and see how do you evaluate that kind of application. So that'll be a first question.
Yeah, it's very big question. And let me share, because I have my kind of GitHub repository of different LLM evaluation tools. I just shared it here, right? And you can go, there is a whole section there about multimodal evaluation. Oh, and I think it's a really important and big topic, right? Because, text evaluation is harder, multimodal evaluation is frequently much harder, right? Because you want to evaluate an image. Let's say you have a image producing LLMs, right, for your e-commerce website, right? And what makes a good image? And there are necessarily multiple dimensions, is it factual representing your prompt, right? But there are artistic quality. There is kind of there are they look into depends on research studies. There are multiple different quality measurements of metrics, many different truthful measurements of image, right? So yes, there are a lot of work on multimodal LLM evaluation. And again, like what I say, text evaluation is very hard, but multimodal perhaps harder. So you can look. So you can look. There is a section in my this repository. There are multiple papers there, and yes, there is a lot of work. And especially if you go to video, it creates own complexity. What I think kind of necessary to understand that like you evaluate text factual answer, kind of readability, few more, right? But image you have necessary many more. Like again, artistic quality, many other quality measurements, right? So yes, there is very big research about multimodal evaluation.
I see. So my second question is related to, see, like right now you're, even though you have a multiple metrics and multiple dimensions, but you measure the end results. But do people, but for the LLM, if you look, especially looking at the RAG type, there's the embedding, there's a ranker, and then a generator. So there's multiple phases. Do you measure, also evaluate each phase separately, or you just always combine the response?
Yeah. So if you look, like you can look at my slide at that, like perhaps I will not because we are talking now, right?
You can share again. You can share again. You haven't.
Okay, maybe let me share again. It will be more easier, right? Share screen. Google Chrome. Let me find it first. All right, so slideshow, right? So yeah, so if you look here, what really you kind of measure each of these different steps, right? So it's kind of picture here, right? So like when you talk answer relevance, right? It's actually measure your whole end-to-end, right? Because you kind of like answer is output, but answer is a product of whole pipeline of context and so on, right? So answer relevance kind of measure whole pipeline from some point, right? But like, for example, when you measure faithfulness, you really measure like how good your answer in respect to context, and you don't look how context was generated. You just have your input context, you have answer, and you want to measure is answer is deduced from context or there is some hallucination, something else, right? So you measure step of pipeline, right? The same about like context precision, right? You have a question and you can like retrieve a context. So you want to understand is this context about this question, right? You don't care what happens after, how answer will be generated from context. At this moment, you measure only this part, right?
I see.
So you see some metrics they measure just, and this is what you want frequently, right? Because like when you measure, you really care about whole end-to-end answer, right? But kind of once you measure this big pipeline of many things inside, and something going wrong, there are multiple different things what can go wrong at different levels. How you're going to tune and improve, right? You don't know, right? That's why you need to have this intermediate measurements so that you can understand, wrong things happens because not because of wrong generator, but because of context retrieval. I want to improve context retrieval, right? So it's necessary here to have this atomic measurement and also end measurement to measure whole pipeline. But atomic measurements at this level are really important. So context precision, faithfulness, they measure sub lines of pipeline, right?
I see. The next question is related to the, there's a two approach in treating the embedding, right? So you go to a vector, do the embedding, go to vector search in the RAG. I'm talking about the RAG part. So you can do the similarity search and all that stuff. And then there's also another group that starts to say, hey, I want to go to graph databases, based on relationships, getting some of the relationship there. So, and I think you should post an article this morning about combine the two. So in that cases, is the evaluation approaches still the same, or how to approach that?
How to evaluate these different types of retrieval, you're asking, just to understand.
Yeah. So it's kind of you get a different type of way to embed, you get a vector database, it's a graph databases, and then you're combine the two and then get the answer. Of course, you can always evaluate the final answer, but in between, how do we measure these things?
It's a really good question, right? And because I feel this question will be more and more important because, like what I see kind of feel like everyone run now to do RAG, but then people build RAG and go very fast into limitation of RAG, natural limitations, not just particular retrieval methods. And people understand, yes, you need to have let's say like fresh prompt type techniques when you use searches at all. You need knowledge graph based retrieval, right? So I believe for any non-trivial business case, customer case, production case, systems will be quite how to call hybrid, right? Multi different. Even the same, like if you build multimodal search, right? And you want to, like in your like e-commerce shopping, right? And you want to use like you want to have text query and you want to retrieve using images. Like you're like, I'm looking for a t-shirt. So you want to understand right from the image or whatever, right? There are many different, more complicated cases. Even in that case, like kind of very particular task, retrieving information using images, no one architecture, there are multiple different architectures, how you can build this cross-modality search system, multimodal search system, right? You can have map search and queries into one modality space. You can transform images to text description and then use them for retrieval, and each of them has own advantages, right? So I think hybrid systems is a necessary future of search, right? For every domain. And here we're coming to the question how to evaluate them. And certainly you will need end-to-end evaluation, like how our system, what percent of user queries it answer correctly or incorrectly, how well is it, what conversion rate, right? It gives you whole driving of your system and understanding what are weak and strong points and how to improve. But certainly it does not give you a particular understanding what really happens, right? So my vision, certainly for such things as like hybrid systems, you will be always using also separate evaluation pipelines for each of those separate systems, right? Because they have own set of problems, own set of bugs, own set of, like again, coming back, using RAG as a system, right? Vector-based retrieval. It will have own ways why it works or does not work well. Versus when you use search as a tool, like you have below a system like Google or some other your search API, right? It has own sets of very different like problems and RAG or knowledge graph, right? And you will need to measure them, to work on them, to improve them, right? So certainly you will always need kind of separate evaluation pipelines for your subsystems.
Yeah, that makes sense. I have one more question, but I want to like give the chance to people online to ask questions. So the one question is, I guess in question answering LLM, if we give the same question to LLM, there's no guarantee that we'll get the same answer every time. So how do we explain this inconsistency or variation in quality of answers to the business customers who's explaining the model performance?
Yeah, it's a really good question, right? So you're like, yeah, so like kind of coming back to everyone, like LLM is necessary statistical model which produces answer by statistical methods, right? And certainly there is a certain level of stochasticity, right? So answers are not always the same. Of course, there is some level of control through this so-called temperature sampling, right? Because LLM produce you set of answers, typically like considering whole neural networks produce set of answers with probability, right? And what answer do you want to select to probability to the user depends on your temperature sampling, right? So there is some certain level, not full, but certain level of control such that you can do like your answer selection from LLM more stochastic. And some use cases actually require this. Like you can imagine, like if you create a kind of generic chatbot, it will be very boring if it will be totally like the same answer always. You want to have some kind of human-like inconsistency. Or perhaps if you build search systems, right? Production search system for shopping site or whatever, you want to do much better predictability, right? You don't want the user surprise. They ask you like, tell me, like, I don't know, best hotels in Toronto. It gives you one and another is totally different set, right? It will be people, they want the same queries, they want to do selection, right? So this is a quite big and important problem. There are different things how to resolve this, right? One is kind of more system things, right? So-called semantic caching. It solves a lot of performance problems such that you have smaller number of calls to LLM, but it solves you some also this type of problem such that you like, if the same user or comes you with the same answer or different users with the same query, sorry, not answer, system produces the same answer, right? It saves you LLM time, cost, but it also gives you this consistency. So there are certain techniques to do this through through kind of more system work rather than LLM work, such that you build on top of LLM caching layer, and it helps you to understand LLM already answered this answer. We have the set, and instead of asking LLM again, and it potentially can produce, first it will be LLM call, it means cost, latency, but it will also produce the same consistency. So there are system level answers. But yes, there are like, again, LLM control level layers through like temperature sampling and other, but it's still like will be still problems the same. So, but there are some, what I described, there are some levels of control such that you can like improve this.
Okay, thank you for the answer and thank you for the question. So I have one question, actually not so much related to the LLM evaluation, but just to kind of see, since you see a lot of these different applications, I just want to see, have you seen federated RAG? Like, for example, you have different organizations have their own knowledge graph, their own RAG retrieval systems, but my organization may need to reach out to the other organizations and then actually combine the answer and then put them together and then do one more retrieval. So have you seen that kind of applications?
I certainly saw this in work, did not see like ready production yet because many people just moving into this, right? Certainly it happens, right? Certainly you see even a lot of cases such that you need one search interface to multiple different data sources and they have own like representations, right? And it's like understood now, right? So yeah, I certainly see need in this. I saw work on that. I am not like really aware, but like really production built use case, but certainly there is understanding that it's needed and people building such architectures.
Okay, thank you. Thank you so much. Any other question from audience? If not, thank you so much, Andrea. I know it's glad you have the whole hour so to explain this. Is I know there's a lot of content, a lot of deep knowledge in your research. Thank you so much for introduced to us. So for
Thank you
those,
very much. Yes, thank you very much for inviting me here. Like, thank you very much for people to attending this talk.
yeah. So we're preparing several other great speaker talks, and hopefully we can make one in June on talking about the confidential computing. And I'm still working with speakers, and the next month, and after that, July, I'm hoping to bring the graph back, with multiple talks. Thank you so much for joining. We'll see you next time. Okay, bye-bye.